g plus ma. Yes. So if acceleration is 0, if a is equal to 0, t is equal to mg. So this is an equation here, and this is an equation here. And okay, if there is the acceleration which is upward, if if acceleration is upward, so t would be mg plus ma. Yes, so this will be the form, which will be t is equal to m into g plus a. If acceleration is downward. If acceleration is downward. So F net would be weight minus tension. Ma would be equal to mg minus t. So t would be equal to mg minus ma, and t would be equal to m into g minus a. Yes. So this will be the form. And for free fall, it's pretty obvious that a will be equal to g, and the prime of this equation can be used. A is equal to g, so t is equal to m into g minus g, which is clearly 0. Yes, that will be the free fall case, wherein the tension will be 0. Back to satellite, we have this critical velocity, the frequency, orbital radius. Back to satellite, and we have this critical velocity. Okay, so centripetal acceleration is equal to square velocity by radius of Earth. V square by r is equal to ac, and the centripetal acceleration is equal to acceleration due to gravity, very much. And so we equate the two, 1 and 2, so we get g is equal to v square by re, and so v square is equal to re dot g, and v is equal to re dot g under the root. So this is very much the critical velocity for the satellite. And if we are to look into the orbital velocity, orbital velocity that the centripetal acceleration has to be equal to the force of gravity. So so basically fc is equal to mv square by r, and fg is equal to gme m by re square. Yes. Sorry, once again, GMME by r square, because this is re plus s, the radius of Earth plus the height. We will look into that later. For now, what is going on? This is A and this is B, and we equate the two. So mb square by r is equal to gmem by r square. M cancels out, 1 r reduces here, so gme by r, v square is equal to it's left on the other side, equal to gme by r. So v is equal to gme by r under the root, and b is equal to gme by re plus h, basically under the root, because total distance is equal to radius of Earth plus the height of the satellite. Yes, so gme by re plus h under the root. So this is very much the general form for the orbital radius for the satellite. This orbital radius for the satellite, how we approximate is how we do it is basically the lines that the linear velocity is equal to circumference covered by time, 2 pi r by t, and we have established that this is equal to gme by r. V is also equal to gme by r under the root. So we equate the two. This is 1, this is 2, we equate the two. 2 pi r by t is equal to gme by r under the root. So squaring both sides, 4, to get rid of the square root, 4 pi square r square by t square is equal to gme by r. So r cube now is equal to gme t square by 4 pi square, and r would be gme t square by 4 pi square to the power of 1 by 3. This is an equation for the radius of the satellite in terms of time period, acceleration due to gravity, and mass of Earth. Me gme t square by 4 pi square to the power of 1 by 3, which is the cube root basically. Now we look into the frequency. The frequency of a satellite is also worth noticing. A frequency of a satellite so the centripetal AC is equal to V square by R. AC is equal to G. Centripetal acceleration is equal to velocity square by radius, and this is also equal to, in the critical cases, this is equal to, in usual cases for satellite, is equal to acceleration due to gravity G. We can equate the two. So this is A and this is B, for example. So G is equal to V square by R. Yes. And V is equal to R omega, the relation between linear angular velocity, and omega is equal to 2 pi by t. The is the basically with respect to the time period, 2 pi by t is equal to omega, the angular velocity. So G is equal to, now let's see, this is C. G is equal to R omega whole square by R. So G is equal to R square omega square by R, or basically we can just say that after cancelling out, G is equal to R omega square, and omega is 2 pi by t, so G is equal to R 4 pi square by t square. And F is equal to 1 by t. So 1 by t square would be equal to F square, so G would be equal to R 4 pi square dot F square. Yes. And if we're supposed to approximate F from this form, F square would be equal to G by 4 pi square R, and F would be equal to 1 by 2 pi G by R under the root. So this is an equation, and once again, if we are to look into this is the frequency, and yeah, F is equal to 1 by 2 pi G by R under the root. This is frequency for the satellite. Okay, so we discussed the flow of a fluid.